Integration by parts is a powerful technique used to integrate the product of two functions. It reverses the product rule of differentiation, allowing us to simplify complex integrals by strategically choosing which part to differentiate and which to integrate. By starting with the derivative of a product and integrating both sides, we derive our core formula. The goal is to transform a difficult integral into a simpler one that is much easier to solve directly. The biggest challenge is deciding which function should be u and which should be dv. If you choose incorrectly, the integral can become more complicated than the original. Fortunately, there is a reliable strategy to help us. The LIATE rule provides a hierarchy for choosing yours u. Functions higher on this list are easier to differentiate into simpler forms, while those lower on the list are better suited to be dv for integration. Logarithmic and inverse trigonometric functions are at the top. Since we don't have simple integral formulas for these on their own, we differentiate them to turn them into algebraic expressions. Algebraic functions like x squared are versatile. Trigonometric and exponential functions are usually chosen as dv because they are easy to integrate and often cycle back to their original form. The intuition is simple: we want to differentiate the part that breaks down into something simpler, like a polynomial becoming a constant, while integrating the part that doesn't get much harder to manage. To solve any problem, follow this four-step framework. Consistency is key. Always write down your u, dv, do, and v values clearly on the side of your workspace to avoid sign errors. Let's look at the integral of x times the natural log of x. According to LIATE, the logarithm comes before the algebraic x, so we set u equal to ln x. We differentiate u to get 1 over x and integrate dv to get x squared over 2. When we plug these into our formula, the new integral simplifies beautifully to just x over 2. After integrating the remaining term, we add our constant of integration, c. By choosing u correctly, we turned a product into a simple power rule integration. In this example, we have an algebraic term x and an exponential term e to the x. Since a comes before e in LIATE, we choose u equals x. Differentiating x gives us 1, which effectively removes the variable from the second integral. Integrating e to the x remains e to the x. The result is a very straightforward calculation. The final answer is x times e to the x minus e to the x, plus c. Notice how the x term disappeared through differentiation, which is the primary goal of the parser method. A common mistake is forgetting to distribute the negative sign to the entire second integral, especially when that integral requires a second round of integration by parts. To summarize, use LIATE to prioritize your u selection. Ensure your dv is something you know how to integrate. If the integral doesn't look simpler after one step, re-evaluate your choices. Quick check: for the integral of x squared times cosine of x, which should be u. Since x squared is algebraic and cosine is trigonometric, LIATE tells us u should be x squared. With practice, the LIATE rule will become second nature, allowing you to tackle complex products with confidence. Thank you for watching this lesson. Generated by Vision Solve AI.